Should we get started? Cool. So the reason I wrote this session is because I work a lot with what we Microsoft call partners. You would probably call them customers. Only Microsoft marketing people knows the difference. Doesn't matter. But I met a lot of them, and they went like, "Oh my God, we are running a monolith, and we were going to go to microservices and Kubernetes, but now some other person told us about serverless. Are we going to die?" And that is a pretty complicated place to start talking about architecture with someone. So the first thing I'd like you to take away from this session is monoliths are fine. No matter what anybody tells you, if it works, it's fine. We don't have to go to microservices. If we want to go to the cloud and want to have scalable things, we probably need to have one of the many different architectures that can help us break things down into parts, so we can scale them individually depending on how much load we put on them. But that said, nobody's forcing you to move to anything if what you're building is performant and works. Cool? Great. So let me tell you a little bit about what serverless actually is. And I'm going to try to avoid most of the marketing hype around it and sort of talk about it from a technical standpoint. Cool? So when I started out doing IT a long time ago, is this the right slide? Yeah, there we go. Had to dirty it up a little bit. There was a lot of decisions to take when you were going to build a server farm. Like you had, which computers are we going to buy? How much RAM do they need? How much CPU should they have? Do we need a UPS? What software should they run? And for a software developer, when they're releasing basically 2 new JavaScript frameworks every minute, that is a complicated thing to keep up with, right? So I'm going to tell you a small story. When I started working in IT as a software developer, people came into my office and asked me how they should configure the UPS. And I'm willing to bet that if there's somebody under 25 here, they might not even know what a UPS is. So, and I mean, for a software developer of today, they would just laugh at you. I don't care. Like, it should run. And it's like, what operating system? I don't care. Run containers or whatever, you don't care. But that was my reality when I was young. And that's most of your reality as well when you were younger. And perhaps some of you are all still living in that reality, right? But through time, we have evolved, right? We've got to something we call infrastructure as service with the introduction of the modern cloud. So we could now reasonably perform and buy infrastructure as a service. Okay, we get our servers, we get everything that we want. We don't have to ask the software developer guy what sort of UPS he needs. And this evolution have continued in the cloud quite rapidly. We went into managed many years ago. How many people run app services? SQL Azure? Cool. So quite a lot of people, 50%. So those are what we would call either managed service, and some people will actually go so far as call them serverless. So the idea behind serverless is basically we remove a lot of options from you. We're going to talk a little bit more about the definition of serverless, because why not get into an argument this early on in the presentation? But the idea is that we remove a lot of decisions from your developers so that developers can focus on how to build applications. This, however, since we're not talking marketing speak here, also means that we are removing a lot of possibilities from you. You get less choices. That also means that somebody else took a lot of choices for you. So if you want to optimize something for performance, that might not be possible, or at least not as easy as it used to be if you were running something more complex. So what is serverless computing? I thought I'd start with Microsoft's definition. If you go to Microsoft.com and type in serverless, this is what you get. Serverless computing enables developers to build applications faster by eliminating the need for them to manage the infrastructure with serverless application to cloud, yada, yada, yada. you can remove half of this text. Basically, what it should say is serverless computing lowers the need for developers to manage infrastructure. And then you can the approach enables developers to increase their focus on business logic and deliver more value. That's not necessarily true, is it? If you have a good team, somebody runs the operations, you're well invested, you're working together with your business, your business team or the people with their business knowledge. I really dislike when we go out and say, yeah, it will give you better performance. Yes, you will be able to focus more on the business needs. Well, we don't know that. It's probable, but we have absolutely no way of knowing that. AWS, we talked about Microsoft, why not talk about the competition? They go so far as to define serverless as putting things in the AWS cloud. So let's strike that out and say serverless allows you to build and run applications without thinking about servers and so forth. Both of these are pretty wrong. And I think the best definition of serverless computing is a cloud computing execution model in which the cloud provider runs the server and dynamically manage the application of managing resources. Wikipedia. Very often the best source of information. But my friend, who is actually here speaking, Glenn, anybody listen to Glenn Henrikson's session? So he tweeted the perfect definition of serverless. Serverless are a problem I want someone else to care deeply about. And then the manager of our event pipeline tweeted, we do. And I think this is pretty good. Like, serverless allows us to focus on code instead of plumbing. We don't have to do infrastructure management. We get scaling. We don't even have to activate scaling. We get scaling out of the box. Somebody provides scaling for us. But like I said before, it also means that we do not get to have the choice of how much we should scale up, scale down, how we should move around with this. That is a truth with modification, because if you start to looking into the different settings, which we're going to do, then you can actually control a bit of that, but we don't get all of those things. So the idea that a lot of marketing people have gotten into their heads, is that the reason that they claim that we get better at focusing on our business need and these sort of things is that we remove this plumbing. So what they mean when they say that you get more focus on your business problems is basically you get more time. You can write your functions and you get more time. And sure, by that definition, I think they're correct. So also when they say you get better efficiency, what I mean is we removed a lot of things that you could configure and we gave you a simpler thing which gives you more time to write code. And that is traditionally the promise of all serverless applications. Microsoft has what I would say 3 major serverless offerings, which would be Azure Functions, the Event Grid, and Logic Apps. Then, depending on how much you want to argue with people, you could say Cosmos DB is serverless. You don't configure it. You just basically spin it up, you buy it, run it. The storage accounts, yeah, could be serverless not, but I don't want to go into those resources. I just see them as sort of like services that you buy for different things. So what I want to talk about in this case is Azure Functions, the Event Grid, and the Logic Apps, which are our offerings, compatible to most of the other cloud providers. And since we're Microsoft, of course, we provide the whole sort of development environment for this. Everybody with me so far? Getting tired on the last day? Any questions so far? So what can you build with serverless? Anything. But it's better for some things than other things. Traditionally, you tend to see it a lot in event-based applications. And when we say that you can build an e-commerce store using this, traditionally, we do not mean that you can do this by replacing your REST APIs. We traditionally mean that you want to migrate into something slightly different. And I'm going to show you a few examples of that. So when we talk about a web application backend, you could introduce a number of Azure functions, for example, as a REST API backend. But the benefit really comes when you expose a web front end, and then we load events from this web front end into a queue that the functions can take care of. Why does that matter? Well, because it allows the Azure functions to scale based on one single data point. How much data do we have in the queue, rather than the web traffic that we get in. So it's basically a better pattern to allow for better scaling, more unison scaling of Azure functions. The same thing goes for mobile backends. In this case, let's say we want to text a message. We're building a messaging app. So I'm going to put a messaging app up to a persistent storage, maybe Cosmos DB, maybe a storage account, maybe SQL, maybe Oracle, whatever. And the Azure function is actually going to look at those specific tables. Okay, say, oh, there's a new message. These are my subscribers to this message, and then publish it out through something like a notification hub or something like this. I'm a big fan of IoT stuff. Anyone big into IoT? One person? IoT is dead, is it? I'm going to sell my stocks tomorrow. Oh my God. So one of the major problems with IoT is, in my case, so I do a lot of sort of things that we bring out to conferences, we bring out to corporations, that sort of thing, that logs data for a small amount of time. It's going to wake up maybe 10 times an hour, measure some data. I'm going to give you a good example. We did something for a wine cellar company. They would like to know the average humidity over a month. So before we came in with sensors, they had I'm going to say monk, he looked like a monk to me, who walked into the wine cellar once every Friday with a hydrometer, looked at it, wrote it on a piece of paper, and left. So when we're saying that they wanted multiply more values, they wanted one measurement every 24 hours. So if we spun up an API for that, that means that now they're paying for a server, or an instance of a server, a container, something like that. With Azure functions, they're paying for what they consume in compute and data, which means that they pay for one access every 24 hours. That is so little, we don't even charge for that. It's basically so little consumption that we cannot bill it. And they went from having a server. They still get the same features. They have the same data, but they just build it in a different way. And in those type of situations, well, Service Fabric. Azure Functions is really nice. It works really well for these sort of things. And I really like them because whenever I have this sort of uneven data processing pattern, it sort of gives me the ability to play around with it and find different solutions. Have you ever heard somebody talk about serverless and say, it depends on how much your traffic varies what you should choose? This is my Stockholm consultant voice, by the way. Sorry to all Stockholm consultants. Anyone heard that? Yeah, you heard it? It's pretty common, like we say, it depends on how much your traffic varies. But that's not true, is it? Like if I tell you on Monday morning, you're going to get a spike in traffic and you're running VMs, how hard is that to combat? We have scale sets. We have automation. We can scale up a VM, no problem. So the actual, what does it depends on which architecture we choose, is the unpredictability of our traffic. Our traffic can vary a lot, but if we can reasonably well predict it, the less interesting Azure functions become. It is when it's very unpredictable that it gets to become a really interesting architectural pattern. For example, in this case, we're talking about conversational bots. How many of you use Siri every day? I don't. But I do it when they release new features for it. I want to try new features. But since they have a rolling update of all the phones, it's pretty hard to actually predict exactly when you're going to get these spikes, depending on work hours and all sorts of data and how often I update my phone and these sort of things. So a pretty useful place in your app, right, to have this sort of data, have the availability, because you don't know when your users are going to update your app and get the data pushed to you. And of course, my favorite example, real-time file processing. How many people have expense reports? There are 3 people in this room who has expense reports. Oh my God, you guys live lucky lives. No expenses. All right, well, that could be good. So you're kidding, right? Like, you do expense reports, right? So I have this problem that in my company, we take photos of receipts and they're uploaded to Dynamics, I think, and then we sort of process them from there. But to enter the data from these receipts, you have to go into each receipt, look at it, and sort of do some work with it, unless you use the specific company credit card and that sort of stuff. So what I did with exactly this pattern was that I started uploading all my photos of my receipts to OneDrive. So I have a folder, OneDrive, receipts, unprocessed. Every time I upload a new one, there's an event grid that goes out with the image. It goes to an Azure function. The Azure function picks it up, runs it through OCR, so Azure Cognitive Services. So it takes the image of this receipt and grabs all the data from it. It reads the text of this receipt, puts it in metadata in Azure Storage, and then renames the file according to this metadata. What date was the purchase done? Who is the operator? Like Swedish Railways, for example, like would be 2020-01-22, Swedish Railways, 600 and, no, that's too low for Swedish Railways, 2,400 Swedish crowns. Just have all the data that I need in the file name. And you can do a lot of these things with real-time file processing. Any sort of file that you want to read, PDF, image, just grab the data. You can grab metadata from the files. You can assemble metadata to them, rename them, do all sorts of these things that you might actually use physical humans to deliver. So it's a very powerful thing. It saved me a bunch of time, especially being wrong to the manager and that sort of thing. And best of all, using Dynamics less. The people who've used Dynamics laughed. One of the first contacts that many of my partners have with Azure Functions is when they had long-running jobs or web jobs in a monolith. So how many people have tried to build a long-running job in your monolith and failed? Just to sort of build a batch script and then run it through cron, perhaps, on a Linux server? It's just me? This is a pretty common thing to sort of end up with, that people have automated tasks. It might be in their SQL Server running as stored procedures. It might be batch jobs. Oh, there is some recognition. Someone went like, yeah. And very often when you migrate to the cloud, stored procedures become less of a thing that you want to use. Cron jobs also becomes less of a thing you want to use because you have to run a server. So typically what you would do then is that you would break out that code and run it as an Azure function. Again, if it's something that you run a few times a day, it might be so little data that you don't even get billed for it. The idea when we're building Azure Functions, we're getting to the tech demos, don't fall asleep, please. The ideas when we're building functions are a few pretty basic things. We stick to the things that we always stuck to. Single responsibility principle. We do one thing with our function. We don't do a lot of things with our functions. It's just sort of a recommendation, not a, you have to do it this way, because sometimes it can be pretty complicated. But I'm going to show you a few ways to get around it. This is sort of the design principles that we talked about. They should be short-lived, they should be stateless, and they should be event-driven. I can agree with event-driven, but then the reason why I put stateless here is because everybody says that an Azure function or a serverless thing should be stateless. But if you watched some of our events this year, you might have noticed that we have introduced stateful Azure functions. So let's go ahead and cross that one out. So they can have state. You just need to sort of know how to build them. And the thing that most people that I've met that used it really likes the most is the predefined triggers and bindings. So what do I mean by that? I'm going to give you a demonstration in a little while so it becomes more clear. But Azure Functions comes with the ability to hook up to a number of predefined features. Like if you want to do an HTTP API in Web API 2.0 or a Python, that's quite a lot of code, a lot of boilerplate code. In Azure Function, it's one property. And you have an Azure function that responds to HTTP. If you want to hook it up to Cosmos DB, again, one line of code, one connection string. If you want to output to Cosmos DB, same thing. And this works for a surprisingly large number of features within Azure. It runs for a surprisingly large number of features on-prem, and there's also other ways, which I'm going to talk about in just a few seconds. So this is really nice. Like they really describe this to me as, yeah, it saves me time. I get less choices, but writing something that just, gets me up and running, it gets me going, is so quick. So it works really, really well. Skip that. So when you're going to run this, and this is pretty simple. Consumption plan is the most common way. You only pay for what you use. The problem with the consumption plan is that when you don't use it for a while, we disable your Azure function. We put it in a lower tier. So that means that when you come back and want to use it, you go into our APIs and you say, hey, I want to talk to my function. And we say, yeah, you have to give us a moment with that one. He's on his break right now. And then we spin it back up. But that means that you might have a cold start on an Azure function that you don't use that often, like maybe 10 seconds, something like that. But that is sort of like the break off between free and paid. The benefit of this, however, is that there's a few ways around this as well. Some of them work, some of them don't work. There's people who basically have a job, a separate Azure function on a time trigger, with every 5 seconds just goes, hey, 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 and just keeps it awake. It works. It's gonna keep it alive. It works. What can I say? But for those people that sort of needs better performance, more scalability, or at least more, it's not more scalability because you get the best scalability in the consumption plan, but if you need sort of more predictable scalability, or if you want to be on your own host, you do not want to share your data host with anyone else. Like you don't want to have the risk of having noisy neighbors or anything like that. Even if we do build technology to avoid noisy neighbors, it's always a risk that we sort of look into. And then there's a number of different plans where you can run this, which goes from free, basic to standard and premium. It's just different sort of things. And I'm not going to bore you with numbers, but you can look it up. And it's open source. So Azure Functions is a pretty cool product. So the next thing I want to talk about was Event Grid. What is the difference between Event Hub and Event Grid? Correct answers gets a pair of socks. Spelling is wrong, sorry. So a lot of people actually do, this is a problem for a lot of people. They could come and ask me, like, what is the difference between Event Hub and Event Grid? Everything is basically the answer. But the biggest thing is that Event Hub, I have to go and ask. If this man here was an Event Hub, I have to go and ask, do you have any message with me? Any messages? Any messages? Any messages? Which is actually quite data intensive. So if we run that for an Azure function, it's going to be constantly polling. It's going to be asking, is there anything new? Is there anything new? Is there anything new? If you write that in an application, well, we all know how costly polling can be when it comes to data, right? Event Grid is push. You just go and say, hey, whenever you have a message to me, you come and talk to me. So I don't have to poll. So when the Event Grid has a message, it spins up the Azure function. The Azure function goes and does the job that the Event Grid said it had for it. So that is the biggest difference. The other big difference is Event Grid can hook up to all of the native Azure features and take all those events from those. So let's say we want to trigger on new files. Event Grid can get you the event of a new file in a blob storage, and you don't even have to configure it. You just have to click in the port a little bit or write a PowerShell script. And when you set it up, connect those things together. Then your Azure function, if they subscribe to that event type, will always get it. So very, very effective. For example, you might want to be notified if somebody spins up a new VM in your production environment. The event grid can take that event, send it to an Azure function that sends you a text message. So it gives you a very big possibility of automating things within the portal, as well as it can take custom messages very, very efficiently and also do push. So if we're doing a microservice architecture, we don't want to do polling and we're not yet comfortable getting started with gRPC, it's a really good alternative within the Azure cloud for microservice communication. It delivers at massive scales. We have sub-second latency to the 99th percentile, 99.99 sub-second percentile. So it's near real time. So every region you can get 10 million events per second. So I do have partners that this is not enough for. So then you go to Event Hub and other things like that. But that's what you get. And you have very high reliability. You have a 24-hour retry policy. The third thing that I mentioned as serverless offering was the logic apps. The most boring of all the serverless offerings. Good. One person disagrees. So I use logic apps for quite a lot. So how many people here enjoy writing in infrastructure code, like code that interacts with other things in your application, in your environment? How many people like when your application has to talk to OneDrive, or when it has to talk to Dynamics or SharePoint or SAP HANA, SAP? Anyone runs SAP? Even Microsoft runs SAP. So when anyone finds you have to write one of these complex integrations to some service, is that fun? I think it's horrible. I like those people that are shaking their heads like, no, it's horrible. And Logic App solves this. It has over 200 and growing connectors. It can connect you to Dropbox, to GitHub, to Facebook, to Twitter, with a click of a button. It's basically a draw. Hello. Oh, there we go. You basically just draw through it, and it will create it for you. So you can go into the portal, go into Visual Studio, get a Dropbox connector. Okay, say every time there's a new file in Dropbox, put this on the event grid. And a lot of developers that I talk to, then it's not code. I don't like it. It's not code. And that's true, sort of. It's JSON. But it's also a lot less work. So I quite like it for that. I've seen people who built really big systems in this, and I'm not sure I like that part of it because that starts to feel iffy for me, but I've seen people do it and been successful with it. So, whatever works. But when we're doing the integrations, this is lovely. I mean, we have basically a 10-second way of getting the data to and from anything that we are using. It even works with Slack and Microsoft Teams. All right. I mentioned some other things as well. I just want to race through these real quickly. Cosmos, for example, some people call it serverless. I would say it's serverless. And everybody knows this, right? Everyone knows Cosmos? Great. Our sort of prime time database handler that it emits lots of great events. It's really, really performant. Who is killing someone out there? No, probably don't, and I'll be a witness. And it's really nice because it can give you write and read ACID across the world. So that's basically 10 millisecond guaranteed latency, and it can synchronize data for you across the world. So it's pretty nice if you're building an Azure function app that is globally scaled around the world. All right. Visual Studio time. We have about 15 minutes left, slightly less. So I thought let's just talk a little bit about how to actually do Azure functions correctly. Should we start with the thing that everybody messes up? Settings! So this is the settings. Oh, God, thank you. Duplicate. I even have a screen there, so I should have seen that. All right, here we go. So within these settings, there are a couple of settings that people seem to forget to turn on. First of all, function worker runtime. This is the runtime that your Azure function will be running in. So if it's writing it in Python, this is supposed to be saying Anyone? Python, very good. You get a pair of socks. And .NET for .NET. If you're running a 3.0, so if you're running on a 3.x runtime, the latest Azure Function runtime, and you want to run code that you wrote for the version 2 of Azure Functions, you set function version 2 compatibility mode to good. And this gives you compatibility with functions from version 2 in version 3. You are only going to activate this if you're encountering issues, because it is 99% backwards compatible. So only if you're encountering issues, otherwise do not activate that. Website Max Dynamic Application Scale-Out. Just rolls off your tongue, doesn't it? Website Max Dynamic Application Scale-Out limits how many Azure functions you can scale out to. For example, so if you're having a Cosmos DB that you're inserting into, and you want to run this cheaply, you're probably going to scale it down a bit, right? That means that if we put in 1 million events in a queue, and we have Azure functions that can scale freely, they're going to kick that Cosmos DB's ass. Because if you cheapen out, then it's not, it's nowhere to go, right? It's going to take the data, and it's going to throw back you an aggregate exception, which is the Cosmos DB way of telling you that you've retried too many times, because that sounds logical, and that it's not going to drop your message. And the thing is, especially if you're using Event Hub, which is appalling, then you went and fetched the message, right? I got the message from that guy. So he now doesn't keep the message. I have the message. And if I'm the Azure function, I can't store it anywhere. I am stateless, unless built with state, but still, I am stateless in most cases. What's going to happen if I can't do anything with it? It's dropped. So sometimes it can be a pretty good idea to run the Website Max Dynamic Application Scale-Out to a number sort of like 5, which means you get 5 concurrent instances of Azure function, nothing more. It can go up to 200 on a consumption plan. Make sense? Cool. How many people like Node? Cool. About 50%. How many people like NPM? 2. That's about bad news for NPM. So website run from package is really good to know if you're running, especially if you're building your Azure functions in Node. So if you're building your Azure functions in Node and you have a lot of NPM, which people seem to do because people use NPM even for is equal or other things like that, or the great one is odd because modular is not a thing. Then you can actually input a URL to zip. So if you deploy your Azure function from a zip file, rather than reading all these files from a deployment, it just reads the zip file and extracts it. So much quicker to get it up from cold start. So if we're doing consumption plan and we want to have it to quickly come back from cold start, then website run from package is the thing to go if we're writing a Node app, or if we're writing, for that matter, a C# app or any app with lots of files in it. Like if we're serving static content or something like that. Cool? Great. So this is the setting. So anything in local let me just zoom in for you. Anything in local.settings is, that is the application settings you're going to set on your application host, right, for Azure function within the portal. So this is just for my local developing thing. So it's not going to actually affect anything unless you do right-click deploy, which we are. Right-click deploy, which we are not to. Very good, you get a pair of socks. Sorry. Then we have host.json. Host.json is where we do all the settings for the actual function that we're running. So in this case, I've enabled application insights so that I can get application insights monitoring from my Azure function. So, and I've also set something like max telemetry items per second to 20. Why have I done this? So if you scale up to 200 Azure functions and you have a lot of telemetry data, your application insights will be able to take all that data and show you a great log. But it's also going to be able to send you a large bill. Because Azure Application Insights is a great product, but we also do charge a bit for it if you're inserting massive amounts of data, like, for example, processing millions and millions and millions of messages and logging a lot of information about this. I've seen people who, for example, take very large JSON objects as messages, like 64K or something like that, which is close to the maximum that you can do, and then log the entire message, which becomes quite pricey. And then it can be good to simply limit the amount of telemetry items. There's also a way where you can limit, and you can actually make the Azure functions drop 90% of all telemetry items, so that you actually don't insert anything. So then because in this case, they're going to be inserted slowly, so still going to be quite a lot of money if you do it. That way, you can limit it down to only get a subset of information. But again, that also means then that you get a less informant log. You can also here go in and say things like event logging level. I think it is. I have to please look that up, but it's something like along those lines. Might not be spelled correctly, and say something like error, that it won't actually log debug or information messages, because you might want to be putting out information messages while you're building it, but when you have it in production, that might become less interesting to you. All right. Settings parts. So what does a basic function look like? Does everybody know? One person in the back knows? All right, let's go through it real quickly then. So a basic function is consisted of a few things. An attribute called function name. In this case, I've named the function function1. I have lots of imagination. This is actually hiding a lot of boilerplate. And it's actually the only thing that sort of gives the Azure function any sort of naming thing. You can actually change quite a lot about the underlying function. So a lot of people likes to name their Azure functions run. You can name them whatever you like. And as long as they have this function name property, Azure function is going to try and run them as an Azure function. They don't care if this one says, I don't know, say, please don't run this function. It's not going to care. It's still going to run it. And this is not going to affect anything, because it's just going to call it function1 and then run the code in it. The second thing that we have here is the trigger, the HTTP trigger in this case. So we're using an HTTP trigger, which means that we're taking, and we're defining that here. We're taking either GET requests or POST requests, and we're having an authorization level of function, which means that our Azure function provider within Azure is going to provide security for us. We could also go in here and say something like anonymous, or admin, or system, that sort of thing. For most types of things, function is great. Function means that you get an authorization key from the portal to use with it, which you then pass into the header. Sorry. So you also have the ability to add your custom routes. In this case, we're just going to pull null and have Azure functions build the route for us. Let's zoom out a little bit so we can go in here. The second event here is the HTTP request. The HTTP request keeps our HTTP request data. Hey, what about that? And then we have the iLogger log. If you notice, there is no other code in this function. This is all that you need for an Azure function. Everything else is boilerplate on for you. So it's going to run all of the other stuff for you. The logging is going to be done for you. So the only thing that I've added up here is this. So I'm going to go through that in a minute, because you need to know this. It's very important, but nobody tells you. Cliffhanger. That's about it. Let me just talk really quickly about this, what this does, and then we can go and look what it actually does and how it actually works. In this case, I have a constructor which takes a dependency injection of a telemetry configuration. You saw me defining the telemetry configuration previously in the host.json, right? This telemetry client allows us to actually start logging things before something runs the function. Because if you're building either, because you can build custom triggers, right? You can build your own trigger attributes that you can run within this. So if you want to put that up and then you want to debug it, and there's something wrong with your trigger, you're never going to get that data because you only log things within your function. So that is a way that you can sort of amplify your debugging information, get more stuff from it, by simply defining this as the constructor of your function. So very good to know. Very few examples that actually show this. Helps me a lot. There's also something called the something I have. Let me put that in the slides later when I upload them so you can see it. But there is an interface which actually allows you to tell the function that I want to log things before you run my functions. There's a separate interface that allows you to create a logging client for information that comes out earlier. It's very useful. Oh, this one reloaded. I had it loaded up with my function. Oh well. So then you get to see how nice the Azure portal looks. Usually there's a lot of haters to the Azure portal, so nothing like that. Be nice to the Azure portal. And let's hope my demos work. In this case, we went into an Azure function. We listed the functions that we have within the system. In this case, we have basic HTTP function. We're going to go here. We see that we have function 1 deployed to this Azure function. So I had it loaded up for you because I didn't want to stand here like an idiot when you wait for the Azure portal over this amazing Wi-Fi to load. Hello, thank you. Let's just get the function URL. Today, I know where you live. There we go. And as you can see here, it has appended a key to this function call. So the code here is our authorization. It doesn't work without this code. So it's appended a key for us. And that is because we configured it for the function to handle authorization for us. So now we can go here and we can add name. I'm inspired by Harry Potter, so we go hello Voldemort. Still just print out this way with it. But it's an extremely quick way to start writing an API or a REST thing that we can do post and everything like that. All right, so let's go into something more interesting than HTTP. Same thing goes if we want to do Cosmos. Same thing applies. It's a Cosmos DB trigger. It's a database name, a collection name, and a connection string. That's all we need. So the same thing applies for almost all types of things that you can communicate with Azure Functions. And you can also write your own of these attributes that works for your company. So you can have company-specific Azure Functions. I have been told. I haven't worked a lot with that, as I do work with a company that sort of makes them for the things that we need them for. Becomes quite redundant. The second thing I wanted us to look at is output triggers. So we have input triggers, which saves a lot of time. Output triggers also saves us a lot of time. So in this case, we have an HTTP trigger defined as our input. So we're taking an HTTP trigger to start the function. But we then define Cosmos DB as our output. And this, same thing here. We have the Cosmos DB, we have the database, we have the collection, and we have the connection string. And we have what sort of document we want to work with. In this case, we've defined an async collection of the amazingly named test class, test class, and simply just give us an object called document to store, which means that in this function, we get ability to, without inheriting anything, without any usings, without new anything like that, every time we work with this function, we have documents to store, which is a Cosmos DB client that we can work with. And I'm not bullshitting you or marketing bullshitting you here, but I can do a function like this that actually does proper work in less than 5 minutes. And I'm pretty fast with web API and that sort of stuff, but I don't think I can do that if I want to access Cosmos with an HTTP, endpoint with security protection hosted in Azure that writes to Cosmos according to a class specification within 5 minutes. But again, as we said previously, it does take away some of our abilities to do more sort of advanced things. It's also quite nice to run these because you have very good local debugging possibilities. So you can actually run these quite well. Word of warning, I just updated Visual Studio to the latest version, and that seemed to have broken the Azure Function CLI tools. It's going to start, but for some reason it takes a lot of time. Normally it's really, really, really quick. It should be solved by the time my bug report is looked at. So while we wait, I was going to show you something else because we're running out of time. There's a lot of really good documentation for this, which also are in my slide deck. So if you download the slide deck, all the links are there. The first one is to optimize performance and reliability of Azure functions. So if you want to have high performance, high reliability, there's a whole really well-written section here on how to do the best practices. Everybody keeps asking for best practices. We heard you and we delivered. Here are all the best practices for scalability and performance. The second one is that we made a ton of code samples for you. If you want to get started with Azure functions, whatever you like, we got you covered there. Ah, there we started in our function. Perfect. Good timing there. So let's say, for example, you want to, yes, I would like to access this. Allow, thank you. Let's say you want to do Azure DevOps release nodes generator. Okay, so when you want to release something to production from your release pipeline, you want to automatically generate release nodes. We got a code example for that. How to set it up, how to run it, how to connect it to Azure DevOps. And there's a ton of really good things here within the code examples. So whatever you want to start doing, like if you want to do smart scaling for Azure scale set with Azure functions, all these sort of things are examples ready to go. Just people wanted examples, we provided examples. Aren't we nice? Almost sounds like we're trying too hard. The extension that you need to work with Azure Functions is the Azure Functions and Web Job Tools extension, which you can either get from inside Visual Studio or from the Visual Studio Marketplace. So when you're debugging, it attaches itself to localhost, so you can work with it as localhost. What's your name, sir? Tommy. I read it off your badge. So we get hello, Tommy. And if we now go into our data, we can refresh it. I'm going very fast because I'm running out of time. And we will have a Cosmos DB says hello, Tommy, with all data from our custom class. We now have 3 more minutes. So if there are any questions, I will happily take them. And then I will have to run to my train.